All right, in this video, we're talking about double angles under trigonometry. Now, in previous video, we talked about compound angles. For us to be able to derive our identities for double angles, we would have to make use of our compound angles. Now, I'm sure you remember from the previous video that we stated our identity for sine A plus B to be equals to sine A cos B plus cos A sine B. So this is our compound angle for sine A plus B. Now it's from this particular compound angle we're going to be able to derive for our sine 2A. So let's quickly find a way to resolve sine 2A. I won't be wrong if I write sine 2A as sine A plus A, because A plus A obviously will be 2A. So from my compound angle, I can be able to find my double angle right from the identity of our compound angle. So what do I have to do next? I have to go on then to resolve for sine A plus A. Now, this is our compound angle, and it told us that whenever we have A plus B, we had this. So in this case now, we will be representing wherever we saw B with A. So that means our sine A plus A will be sine A, now cos A plus cos A sine A. So if you can look at this, you would be able to observe that we have sine A cos A, we have cos A sine A. I won't be wrong if I wrote this as, instead of writing cos A sine A, I can also write it as sine A cos A. Obviously, sine A times cos A is the same thing as cos A times sine A. Now you can see that sine A cos A sine A cos A is represented in the two places. So this will obviously give me my value to be 2 sine A cos A. So this is our very first identity, and I can conclude that my sine 2A, that means the double angle when I'm dealing with sine, is given as sine 2 sine A cos A. So you need to note this down. This is one of our new identity under double angle. So let's go on to try and resolve for cos A cos 2A. So we've been able to find for sine 2A. What if we were going to find for cos 2A? What are we going to do? Now don't forget that we have our compound angle for cos A plus B given as cos A cos B minus sine A cos B minus sine A sine B rather. This is from our previous video. I'm sure I stated this identity very clearly. So in this case, when we're dealing with cos A plus B, we had this. But don't forget, our cos 2A can be written as cos A plus A. So obviously, we can make use of our compound angle to resolve this particular function. So our cos A plus A will be equals to cos A, using the compound angle for cos A plus B, but in this case, we'll be replacing A with B. We'll be replacing B with A rather. So cos A, no more cos B now, cos A minus sine A, no more sine B, but rather sine A. So that will be cos. So we can conclude that our cos 2A, which is cos A plus A, is equals to cos A times cos A will be cos square A minus sine A times sine A will be sine square A. So this obviously is the second double angle identity that we've been able to successfully derive. Now, but I need to show you that for this cos 2A, we can have two other different formats to write the identity. So we have cos 2A, but don't forget that sine square A plus cos square A is actually equals to 1. So if I decide to replace cos square A with 1 minus sine square A, I would not be wrong. This was one of our basic identity right here. So I can replace wherever I saw cos square A with 1 minus sine square A. And what's going to happen there is that I will be having a new different form where I can write my cos 2A. So rather than writing cos 2A as cos square A minus sine square A, if I replace cos square A with 1 minus sine square A, then I will be having a new different format for my double angle identity for cosine. So this will give me, obviously, when you equate, this will be 1 minus 2 sine square A. So this is another different form in which I can have my cos 2A identified as. So we have this very first form and we have this second form. But what if I decided to not make use of cos square A with 1 minus sine square A, and rather I decided to solve for sine square A, which was equals to 1 minus cos square A. So if I decide to replace sine square A with 1 minus cos square A, what's going to be the result? Obviously, I'll be getting a different form. Of course, still the same thing, but just in a different form. So I'll be having cos square A minus, in this case now, replacing sine square A with 1 minus cos square A. This is 1 minus cos square A. This will obviously be cos square A minus 1 plus cos square A. Cos square A plus cos square A will give me 2 cos square A, then minus 1. So this is the third format that I can have my cos 2A written as. So you can make use of this first format, or this second format, or this third format, depending on the particular question you are dealing with. Of course, 3 of them have a role in different questions, so you can always know how to make the adoption of the 3 different forms depending on what question you are dealing with. So let's go on to solve for the last double angle, that's for tan 2A. So from our compound angle, we know that tan of A plus B was given as tan A plus tan B over 1 minus tan A tan B. So when we're dealing with tan 2A, obviously I can write tan 2A as tan A plus A. So I can go on to solve for tan A plus A using my compound angle formula, but in this case I'll be replacing tan, instead of having A plus B, I'll be having A plus A. So wherever I see B, I'll be replacing it with A. So what we have here is we'll be having tan A plus tan A over 1 minus tan A tan B. So when you go on to resolve this, tan A plus tan A will be 2 tan A all over 1 minus tan A. Sorry, we are not having tan B again. We are having tan A. This will be tan A times tan A will be tan square A. And this brings me to the final conclusion on our double angle. So we are having the tan 2A given as 2 tan A over 1 minus tan 2A tan square A. So that's going to be the 3 different the solution for the 3 different double angles: sine 2A, cos 2A, and tan 2A. So what I'm going to ask you to do for practice and is for you to go on to investigate what do you think is going to be cos 4A, what do you think is going to be sine 4A, and what do you think is going to be tan 4A. I want you to go on to investigate this, and you can let me know how you are able to cope with this in the comment section. So just to give you a hint on this, when you're dealing with, for instance, sine 4A will be sine 2 times 2a. So in this case now, wherever you saw in your sine 2a, which we have derived, wherever you saw a, before you had sine 2a, wherever you saw a now, you'll be putting 2a. So that's the clue for you to be able to solve that successfully. All right, guys, thank you for joining us. I hope to see you in the next video. Bye-bye.